Mic check, 1 2 1 2. Alright, for our AQA kind of visitor here, really quick, 2 minutes on the national grid, which is not on the year 11 syllabus if you're doing CCA, so don't panic, we haven't actually started yet, we're still on 3 minutes of countdown, but here we go. Alright, so you start off here with your power generation system, so this is your generator here, or your power station. Right, got that there. Right, next thing you need to do then is at your power station you go up onto the super grid. Okay, so in order to do that you need to up your voltage so that you're reducing energy loss in the wires. So right here we have a step up transformer. Right, so you step up transformer. This leads you on to what is called the super grid. Right, with huge voltages flying across the lines. No use for anything really except for transmission. So super grid here. Alright, now across the super grid then we pop onto our regular national grid around here. Okay, so we'll step down onto the regular national grid. So we step down to there, so we'll put a step down here. So once we get across like major countryside and stuff like that there, we end up on the national grid. That grid. There. Okay, so from there your national grid travels on and it can then split into a variety of positions. Okay, so you will have a next step down transformer which will step it down to kind of still pretty high voltage, but nothing like the super grid or the national grid. You step down off that and you end up at heavy industry. Okay, so we're going to step down here. Right, with 1 minute 56, let's see if we can explain the entire national grid to you. Right. Next bit across then we've got a further step down transformer. So let's select that, give that a copy. We've got another step down transformer. That steps down a little bit further. And then we get to light industry. Oh, the good music's coming in now, so we're running out of time, so we're at light industry there. And then finally we have our last step down transformer, which is the one that you're interested in, because this step down transformer then leads to your houses. This is for domestic use. Okay, so domestic use. Hope that's cleared that up for you. That's the one you want. Probably want to take a screenshot of that and run back a few minutes because that was quick. But we'll pop back to the countdown for a minute to go. Okay, CAD site shout out there because I've left my mic on, so why not? Okay, ladies and gentlemen, welcome. It is 20:33, we're 3 minutes late, but we are hopefully sounding great. Just a check and chat, the mic is coming through, and we are going to take a look at some last minute revision for our year 11 exam tomorrow for CCEA. So if those of you who join us from other exam boards, this is CA only. Alright, so if you've got a particular burning question that you want to have answered in the chat, pop it in the chat and we'll certainly get to that. Right, so we're going to start with probably the one question that causes a little bit of fear and anxiety in the exam question, and that is the kind of the data analysis question, the one where you're going to get something that's based on a topic you've never come across before, but it's got a pretty standard format, and we can do some predictions in this. So let's imagine that you were given this set of data, and there'll be some preamble to this, and you will read every single word of it. Okay, every single word of this. needs to get read because it's going to give you vital information. But they've given you some form of length L in meters, and they give you some numbers 10, 20, 30, 40, and so forth. Then we've got B/seconds, so that's some number B measured in seconds. And then we've got some blanks. Okay, CanSite is disappearing from us. See you later. Thanks so much for turning up. So we've got some blanks here, and then we've got B squared with a blank here, and then 100, 150, 200, 250 as our results. Alright, so what we want to do in this one is we want to have a little look at what they might ask us. So this is the most complicated you can possibly get, and they'll say something along the lines of that these two things are related to each other in such a way that perhaps B squared is equal to K times L plus that's some other number, let's call it P for the sake of it. So that's your equation for this. They've been told you to relate that. So stage one of this will be to fill in the values for B. Now we can go through this whole process here of attempting to do a calculation, but that's a really bad idea. We've been given what B squared is, so we just go and reach for the calculator on this one and then fill in our values for B. So the value for B will simply be the square root of B squared. So the square root of 100 is 10. The square root of 150 is not something you should attempt to do in your head whilst you're in an exam situation because it doesn't come out nice and easily, but you grab your calculator and you get 12.25 for that. Watch for things that say maybe just to one decimal place on that. That would be quite a useful thing to do. Then we've got 200, so we want the square root of 200, and that is going to give you 14.14. And then the square root of 250, which we will pop into our calculator again to make sure we've got our answers right, is 15.81. And you've got your first couple of marks in the bag. Now this next bit here will ask you what's the unit for B squared, and that's kind of curious. So we'll take you through the process here. B squared, mathematically speaking, is B multiplied by B. So for the first one, it's going to be 10 multiplied by 10. But not really, because B is measured in seconds. So it's not 10 times 10, it's 10 seconds times 10 seconds. And this then becomes an algebra problem. You've got 10s times 10s. So you do the number multiplication first, which is 100, and then s times s is s squared. Okay, so even though they are units, they function in exactly the same way as algebraic numbers do, or algebraic letters do. So what we need to do here is we know that B squared is always going to end us with a little leftover s squared that we have to deal with, and that is our unit. Alright, so that tends to be the kind of first section of that. So you've got 3 marks on the board there probably for that. You're not getting much for s squared because you can just look at b squared, seconds squared. It's, you know, the explanation down here is not entirely necessary, but useful nonetheless. So then what we've got to do is we've got to go and plot this graph. Alright, so I'm going to grab that table and take it to a little axis here. Alright. Now, normally speaking, what you'll get in an exam situation is you get a little bit of help. They're not complete monsters. So we'll take this and put it up in the corner somewhere. They're not complete monsters. So we've been given our equation B squared equals KL plus P. So they'll almost certainly tell you to either put what the value for the y-axis is or what the value for the x-axis is. So we're going to pop actually they wouldn't give you that one, they'd give you L in meters here, because if they gave you the axis and the y-axis they'd give away the kind of B squared one. Okay, so up here we're going to have B squared, and then you'll be left to fill in the second squared bit yourself. Okay, and you'll be directed to do that. And then all you've got to do is plot the results on that. So what we need is we need a scale across the bottom. So we'll start at 0 and we'll go 10, 20, 30, we have to go to 40. This is a terrible scale. If I was marking the paper, I would seriously do me in, because I would want to use as much of the lower scale as I humanly could. But we're in a hurry. We're on last second cramming, so let's crack on. And up the side we've got 100, 150, 200, 250. So we'll start at 0 and we'll go up in 50. So let's go 50 here, and then we'll move up to 100, which is less fun doing this vertically. 100, 150. We'll put the numbers in, we have to move them out, we'll do that, 200, and then 250. Now, The exam board are moving a lot more towards marking online. I'm not sure if the year 11 one's marked online this year or not, but I would expect that it will be. So we've got a couple of techniques that we want to use for online marking. So when we plot our points, we want to plot them with an X. Okay, so find your spot that you want to plot it. So that's 10 across to 100, and place an X there. So that's around about there. The reason we have an X is, first of all, when the papers get scanned, sometimes a dot doesn't come out quite right, definitely in the quality of that. And also we're going to draw a line later. So we want to be able to see our points after a line, because ideally we're going to draw a line that's going to go through our points, so the line's going to completely obliterate the points that we've drawn. Right, so 20 goes to 150, so that's, this is handy enough little graph to draw. Then 30 goes to 200, and then 40 goes to 250. So you've got this type of situation. You get 3 or 4 points for marking this graph on, and then another point for drawing your line of best fit, which, if you've drawn it anyway vaguely accurately, should be a perfectly straight line. Now for guesstimation on a screen, I'm going to call that a win. Okay, good. So now we've got the analysis part. Analysing this graph becomes a little bit more interesting. We need to be able to calculate our value of K and our value of P. So there are a couple of ways we can do this. We can take a couple of points and we can start doing simultaneous equations all over the place, which we really would like to avoid doing if at all possible. But we've been asked to draw a graph, so let's take a look at the things that are on our graph. We've got B squared and L, right? So B squared was on the y-axis and L was on the x-axis. We've also know that this is a straight line, and it's a straight line not going through the origin, as we've noticed. I'm hoping we've noticed anyway, that this does not go through the origin. Okay, so we know that this is going to follow the form y equals mx plus c. So we'll put the m in, and then we'll put the plus c in here. Right, now if it did go through the origin, there would be no plus c part here, because c would be 0. So you just have b squared equals kl, but in this case we've set it up to make it as complicated as humanly possible for you. We're in last second cramming mode. There's no point easing you into it. We may as well go for the absolutely mental whatever. Right, so we've got a straight line. It has the form y equals mx plus c. Now what we mean by the form is that the y-axis value should be on its own out at the side. There should be then an equal sign, then there should be some other number or letter, or some other group of numbers and letter that are constant, then the value of your x-axis, and then plus something else. And we've got this form. We've got b squared on our y-axis, some number, the value of our x-axis, L, plus some other number. So what we need to do now is draw a couple of lines up and down. So K is the equivalent of M, and P is the equivalent of C. So we can say that K is equal to M, and M is the gradient of the line. We can also say that P is equal to C, and C is the y-intercept. And now we have, and if I could spell intercept that would help, there we are. So now we have all the information we need to complete this question. So we're going to take these two bits of information, copy that across to our graph so that we can do some analysis. So let's start with finding our value of K. K is M and M is the gradient. So to calculate the gradient of a graph, we want to take the change in x divided by the change in y, or the rise over the run, depending on how you do it, or y2 minus y1 over x2 minus x1, depending on what your particular flavour of maths is. Now I've always been rather partial to a little bit of Greek, so I quite like the delta. So we've got delta y, the change in y, divided by delta x. Oh, capital delta, big triangle, divided by the change in x. So delta y over delta x. If you've never seen that before, don't panic. Delta just means change in. It's a shorthand. Okay, so my change in y divided by my change in x is going to equal my gradient, and equally, because it's equal to my gradient, it is equal to my value of k. So let's go get ourselves a little triangle sorted out. So grab myself a dotty line and do the construction. Spend the time and get it right. It is worth it. It's going to be worth a few marks to you. So we'll need some. We don't want any start or end styles in this. We want to make ourselves a large triangle. So we're going to pick a point handy to us. There's 40. And we're going to run that up, and we know that goes up to 250, at least it should, and 250 should be perfectly on my line, so I'll just move that into place. So that's my first set of points, and I'm going to run that across to my y-axis so that I can pick the points off nicely. So that's point 1 of my triangle. And then point 2, I'm actually going to pick, it's not just necessarily pick the first one. Let's do that. Let's pick that point, okay, at 10, 100. Okay. Now, you can pick any 2 points you like, but the more accurate you want your answer, the further apart you want these points. Okay, makes any little error you make in reading them not particularly difficult. If it goes through 0, by all means, in fact, I insist that you use 0 as one of your first points, because you know that's right. Like 0, 0 is certainly going to be a point if it doesn't have a y-intercept value. So use that as your first point, and then you're only really reading 1 point, which massively cuts down your error. Okay, so this then gives us a little right angled triangle, so going up along here, down to here, and down to here. Okay, so my change in x, which is in this direction, is the change between 10 and 40. So that's 40, take away 10, which is equal to 30. And my change in y is I go from 100 up to 250, so that's 250, take away 100, which is equal to 150. Okay, so my change in y is 150. My change in x is 30. Not 230, just 30. Big fingers, small keys. I pop that as a fraction. Ooh, wrong line, wrong line. And then we just evaluate that. We go, right, okay, pop that into your calculator. I know it's straightforward to do, but in an exam, get your calculator out and make sure that it's straightforward. 150 divided by 30 is going to give me 5. And that's only part of the story, because if I'm an evil examiner, then what I want is I want to get the unit of this. So delta y is 150, but it's not really 150, it's 150 seconds squared. Yep. Okay, because it goes from 100 seconds squared up to 250 seconds squared. So delta y is 150 seconds squared, and delta x is 30 meters, because it goes from 10 meters to 40 meters. So my unit is the bit that's left over. I did the numbers bit, but I'm technically left with s squared over m as something that I haven't actually figured out yet. I've just completely ignored it in my mathematical treatment, and that's because it's going to become my unit. That the answer here is 5 seconds squared over meters, which is much more commonly written as 5 seconds squared over meters, or per meter. So 5 seconds squared per meter. And this is a particularly nasty little question, because you've seen meters per second squared and you're desperate for it to be that way round. And that's why it's a good one to use as an example. You trust your maths, you trust your process, and you make sure that you get it right. Okay, so 5 seconds squared per meter. And then our last part then is to calculate the value of p. Well, down here we say that p is equal to c from our y equals mx plus c analysis, and c is the y-intercept. So all I need to do is get my extra special vision on and go, right, where does this actually hit the y-axis? And by hit the y-axis, I mean when x is 0, what is the value of y? And on my graph here, when x is 0, y equals 50, so p is equal to 50. But what is the value? What is the value of the y-intercept? It is 50 seconds squared. And that's how you take that one and sort them out. Okay, so that's your graph question sorted out. It's the only other thing that you get asked here is b squared directly proportional to L, or is L directly proportional to b squared? And in this case you can say no, it is not directly proportional. It is proportional, certainly. There is a straight line going on, but that straight line is not going through the origin. In order to be a directly proportional relationship, you need to have two criteria. Criteria 1, it's a straight line. Criteria 2, that goes through the origin. So that's the graph bit sorted out. So on to the next little bit here. I'm going to have a little crack at having a look through here on the chat. Looks like lots of people are being quite passive this evening in terms of what they want to know. So let's crack on with the next thing that I sort of have pre-planned here, which is dealing with 6-mark questions. In most cases, the 6-mark question isn't something that you should be overly afraid of. The method of marking is that one of those marks are available for quality of written communication. So you're really looking for 5 key points on any of the topics that you want. Let's pick yourself something ever so slightly random. Let's pick something along the lines of how would you measure the average speed of let's say a car, a toy car rolling down a ramp. Now this is probably not a question that you've answered necessarily in class before, so the automatic impulse here is to panic. You're going, oh no, what am I going to do here? So relax is the first thing. Let's pick out our keywords here. Okay, average speed is probably the most important thing here. This is the physics. Everything else is situational. The actual physics of this is average speed. So how would you calculate the average speed of something? Well, average speed has a couple of equations. You can have speed equals distance divided by time. That'll do it. Or average speed equals your initial speed, u, plus your final speed, v, all divided by 2. Right, so those are your 2 choices, and how you choose to set up your experiment is entirely now up to you. What's the best way of doing this, or ideally the simplest way of explaining this? So if I wanted to calculate the average speed by this method, I would need to have some method or some piece of equipment in my lab that would allow me to measure distance and would allow me to measure time. And straight up you can go, right, okay, distance you're probably talking meter ruler, tape measure, that type of thing. Time you're talking stop clock. For average speed is u plus v over 2, we need 2 speeds, a start speed and a final speed, and in both of those cases that's not just quite as straightforward. It's doable, but you're probably talking light gates, and that sounds like no fun whatsoever, especially with a toy car, because we know that light gates require trolleys with big interrupt cards on top of them, if we remember our stuff back from Newton's first law. So I'm not touching that with a barge pole, though it would be an acceptable exam answer to sort that out and get to it. I'm going to reject it for the sake of simplicity. Right, so let's get ourselves sorted out. How would you measure the average speed of a toy car rolling down a ramp? Right, so let's get a setup. We're going to have a ramp, probably at some form of angle. Right, grab a toy car. This should be interesting. Okay, a couple of wheels. And we'll drop a rectangle on top of it, and that'll maybe do us as our toy car. Yeah. Graphics design students, hope you're paying attention. Put a wee fill in there, so there we go, look at that, beautiful, beautiful. So we've got a ramp set up at some form of angle. We've probably got our table in here, and we may actually get a mark for drawing this diagram, especially if we say set up the equipment as shown with a ramp elevated slightly off that. We'll maybe grab a little stack of books to hold the ramp up, or a retort stand or something along those lines. So I have no idea what I'm doing here in the exam. I'm literally crapping myself, going, oh my goodness, well, what am I planning? But you take it a step at a time. You go a little bit at a time, and you sort yourself out. Okay, so fill in my ramp, and give that a nice brown color, and bring it to the front. There we go. That's beautiful. Okay, so one ramp. So I need to measure speed, distance, or I want to measure my average speed, so I want to use distance divided by time. So I need to now measure the distance here. So point 1 is set up the equipment as shown. Point 2 will be measure the length of the ramp. That's your first mark on the board with a ruler or tape measure. So in a simple experiment like this, you're probably looking at a mark for the actual measurement and then a mark for the piece of equipment that you're going to use there. Okay, so that's your second mark and your third mark. Your fourth point then is going to be let go of the car. So let go of car, and time, how long to get to the bottom. Point 5 with a stop clock. Point 6 then is going to be repeat. I'm running off the bottom of the page, that's no use. Okay, repeat, and we repeat for reliability. And spelling and that's better. Spelling and talking, harder than you'd think. The key thing here in reliability is we do not repeat for accuracy. Never ever say that. It's R for reliability. So repeat for reliability, and then adjust your apparatus for accuracy. All the A's for accuracy, all the R's for reliability. Okay, and then number 7, use speed equals distance over time to calculate it. Now you'll notice there are 7 points here. Depending on which ones the examiners make a priority, the points could be all 7 of them there, and it could be any 5 from, plus 1 for quality of written communication. Alright, so that's the plan. That's the plan. Right, anyway, moving onwards, that is how to approach a 6-mark question. Just relax yourself. Stay in the zone and just go, right, what's the equation here? What's the physics that I know about the key term up here? More difficult ones tend to be content based, looking at things like describe nuclear fusion. But you go, right, nuclear fusion is when you put 2 nuclei together. So we'll start with that. We'll start with 2 light nuclei are forced together. What does that make? That makes a heavier nucleus. Why are we doing this? We're doing it to produce energy because some of the mass goes missing. Now, what is it that we use for this? In much the same way as I've got a measurement, I've got some description of physics going on, but what's my equipment? What are we using in terms of making nuclear fusion happen? We're looking at using deuterium and tritium because they're the ones that are most likely to cause a fusion reaction with the least amount of energy required as the input. And then there might be a little prompt saying, okay, why is this not able to be done just yet? And you talk about the enormous amount of pressure and temperature required. We're not looking for huge amounts of waffly detail. This is science, as simple as possible, but no simpler. Okay, so next thing we want to take a look at then is exam technique in terms of number of marks, especially if you're a grammar school student and you are used to getting very difficult questions all the time. The marking criteria is generally this. 1 mark is just recall or simple thinking. So something like, state, or what is the equation of Newton's second law? Just F equals ma, bang, you've either got it or you haven't got it. Put an X on the center of gravity of this object, you've either got it or you haven't got it. Okay, what's area measured in if pressure is to be in pascals? It's meters squared, you've got it or you don't have it. Okay, or simple thinking, something like convert 1,000 grams to kilograms, and we'll do a little bit of conversions later on. Okay, 2 marks is generally speaking either difficult recall or a simple calculation. So for example, if you're doing speed equals distance over time, that'll be 2 marks. It's super straightforward. So it's unlikely that they're going to give you a 3rd mark for writing such a simple equation without any form of rearrangement. Distance equals speed times time, maybe a little bit different because you have to take the original equation and move it around a bit, but definitely simple calculation there. Difficult recall for 2 points, something along the lines of the principle of moments, which will be 1 mark for saying for the object to be in equilibrium, 1 mark. The sum of the clockwise moments is equal to the sum of the anti-clockwise moments about any given point for your 2nd mark. Okay. Then on to 3 marks. Rare that this would be for a written question, but 3 marks is probably a calculation question. Okay, so calculation on that. F equals ma. P equals mgh, or EP these days. Kinetic energy is a half mv squared. Those type of calculations, ones that have multiple steps to them, possibly involving more than 1 variable. That's 3 marks on there. 4 marks, hard calculation. With one of 2 possibilities, either you have 2 parts to the calculation or you need a unit. is where you get your 4th mark. So you might get something like pressure. Pressure equals force divided by area, and give the unit at the end. So you have to get your force in newtons, your area might be in millimeters squared. You do the calculation, get like 48, and then understand that your unit is going to be newtons per millimeter squared. And then you get your 4th mark for that. Or a hard calculation might be something like calculating the resultant force on an object first, and then using that answer to calculate the overall acceleration of a plane or something along those lines. 5 marks rarely happens. Very, very rare, the 5 marks. You're probably jumping then straight to 6 marks, and that's your essay question that we've just covered. Okay, so really, really, really do take the time. If you've done any form of past paper question in preparation for this, you will note that the exam paper is about an hour long. There's no way you're not getting this paper finished. So read everything, check the marks, and make sure that you understand what is expected of you. Alright, now last one then. This came up as a little bit of a problem. It always comes up as a problem. The Newton's second law question. Alright, so let's try it in its most difficult form. Okay, so let's give ourselves something like a tank of water. A tank of water is quite good. So get ourselves a little box, fill that with a nice watery, that's not watery type, there we go, that's better, but that's not watery, the water's colourless, but you know, we'll let it go. So we've got a little bead of something falling through the water, like this. Alright, let's make it a little red bead. Okay, now acting on this bead, we have some form of resistive force backwards, and we have some form of accelerative force downwards. Okay, so we're going to call this this backward force the drag, which is the general name for anything when it's moving through a fluid, so that's liquid or gas, and our force downwards is of course going to be our weight. Alright, now let's say at this given time this object is accelerating downwards with an acceleration of 5 meters per second squared. Right. Now it has to be less than 10 because things that are falling freely fall at 10, so this thing's being held back a bit, so it's accelerating a little bit less. Right, so let's get a bit of information. Let's say the mass of our bead is equal to 250 grams. Let's make this as hard as possible for you. Okay, so part 1, calculate the weight of the bead. Okay, it's not really a bead if it's 250 grams, but anyway. So here we want to use our weight equation. That W is equal to mg. That weight is equal to mass times the force of gravity on planet Earth. So the weight is what we're trying to find out, so we're not expected to know that. The mass, we're super tempted to put 250 in there, but we wouldn't. That would be silly, because we know that the mass in any force calculation, and this is a force calculation, has to be in kilograms. So that's 0.250 kilograms multiplied by 10, the acceleration due to gravity, which gives us a weight equal to 2.5 newtons. And as soon as I get that, I've got that knocked into the diagram before I even read my next question. 2.5 newtons downwards, because I know what's coming. I've done enough practice to know that we want to then calculate the drag force acting on this, and this is going to be at least 4 marks. In fact, this might be one of the rare examples of where you get a 5-mark question. So we're being asked to calculate a force, so my immediate impulse is to reach for Newton's second law, F equals ma. So let's pop that in, because we have m and we have a, that F is equal to 0.25, the mass, or 250 as we said earlier, times the acceleration, which is 5. So that gives me an overall force F equal to 1.25 newtons. And that's going to be in the downward direction. Has to be in the downward direction because this thing is accelerating downwards, and my overall force has to act in the same way as my acceleration. So we know we've got 1.25 newtons downwards. Alright? Now that's weird because our weight's 2.5 and we've got 1.25 down. What's going on there? Well, that's because F is not the force. Right? And it's one of those things that people keep saying, that force is equal to mass times the acceleration. You've got to be careful here. This is the resultant force, okay, which is, if I could manage to completely redraw this diagram with just a single force, the only force acting on it would be 1.25 newtons in the downward direction. But that's not what we've got. We've got 2 forces in this diagram. But what we do know is that the resultant force is going to have to be equal to the weight take away the drag. Now I know it's weight take away drag because I know the weight's bigger, because I know it's accelerating downwards. If it was coming upwards, you know, maybe the buoyancy force or the push force upwards was greater than the weight. You know, like so somebody dives underwater and then they kind of float up to the top. But in this case, we're not accelerating upwards; we're accelerating downwards. So I know my downward force is bigger. So I know it's going to be weight take away drag. So my resultant force, which I've just calculated, is 1.25, is equal to my weight, which I had as 2.5 before. Take away my drag force, and we'll call that D. Alright, so at this point we need to do a little bit of rearranging. So I'm going to take away 2.5 from both sides, and that gives me negative 1.25, and I'm having a little bit of a panic when I see a negative, equals negative D. It's okay, the negatives will cancel each other out on both sides, so that gives me that D is equal to 1.25. So my drag force is 1.25 newtons. And again, I'm getting 4, maybe 5 marks here. I'm getting 2 or 3 marks up here. This is a big chunk of my exam, so I'm coming back up here to put in 1.25 newtons in the upward direction, just to make sure that my final diagram still makes sense with the physics that I understand, which is I have 2.5 newtons down. I have 1.25 newtons back up. Does that lead to 1.25 newtons downwards? Absolutely it does, because that, take away that, gives me that. Alright, so that's us. We are pretty well done on this topic, and I can't think of anything more that's going to be difficult for you. The last thing I want to talk to you about then is moments. This came up on a past paper question that we were going over in class. Just to reiterate the point that if I have some form of pivoted system, okay, so there's my little circular pivot down there, we'll mark that in a moment, and I have a force that's being applied to it here, and then some sneaky examiner with his maximum sneakiness involved gives you a distance there and a distance there, and let's say this distance is let's say it's 2 meters, and this distance here is, call it 1.6 meters. I give you a force over here of 10 newtons, make the math simple later on. What we have to do here is we have to calculate the moment. Okay, so we immediately go moment equals force times distance from pivot. We get our marks on the board for that. Okay, capital F for force, silly me. And then I go moment equals, my force is 10 newtons times my distance, and I have a little pause because I've got 2 distances here. And which one do I want? Now, my immediate instinct is to reach for this one because there's the pivot, there's the force up there. It makes sense that this would be right. But if you have it in a situation where, think about this, if I rotate this round till it's up here, is there ever going to be a situation where this is anything other than 2 meters? This is always going to be 2 meters, and we know that the moment gets less and less and less as this thing gets up further and further and further. Like when it gets up vertical, the 10 newtons won't make it turn at all. So actually it's this one here, and the rule for this, because that's a bit too logical to have to figure out, is, well, I've got this arrow. It's kind of arbitrarily drawn on. Like I could have drawn that arrow all the way down through here, and theoretically I could have drawn it all the way back up through here. I could make this line infinitely long. And this is the idea, that the distance from the pivot that you wish to measure is the distance that comes from the center point of your pivot, or from whatever point it is you're taking moments. It doesn't have to be the pivot necessarily, but the pivot usually, all the way across to my line of force in such a way that it meets that line at a right angle. Okay, the moment is equal to the force multiplied by the perpendicular distance to the pivot, and that's what we want. Okay, so it becomes 10 times 1.6. And we're nearly there, but we get all excited by being really clever, right? Because everybody likes going, haha, Mr. Examiner, you didn't outsneak me, I'm as wily as a fox. I've got the 16 here, and I want to go Newton meters, and you're probably done. You're probably done, but let's go for extra credit. Let's go for super suave points on this. Let's get a direction as well, because a moment is a type of vector. It has a direction applied to it. So let's work out what direction this is. So imagine that you're holding this here. that you've got one hand, you say put your left hand, put your finger on the screen where my mouse cursor is now. Unless you're on a touchscreen device, don't do that, that would be dreadful. Then try and imagine pushing this downwards. Okay, and this thing is going to turn in this direction. Let me see if I can get a curvy line going on here. Oh, curvy lines. Okay, but it's not going to go that way there, it's going to go like that. Okay, so this thing's going to arc kind of in this direction. This is the most terrible thing I've ever seen in my life. Anyway, it's going to arc round this way. Okay, which is exactly the same way that a clock goes. So this is therefore 16 Newton meters clockwise. And we're done. Okay. Happy days. Alright. Just a comment in the chat from Shane. Yeah, the double award exam is tomorrow afternoon. The triple award exam is like next month sometime. But it's useful to be here on this one. Alright. At 9:10, I've kept you a little bit longer than the half hour I promised. So unless anybody's got any burning questions that are in the chat, which I don't see as I'm having a little look through here. Llama Llama says you'd love to know about C2AS maths. Yeah, cool. Ask your maths teacher on that one. Mr. Curlin might be a little bit busy this evening, and I didn't get the Fry and Doherty's as you recommended. I'll maybe leave that to later on the end of the term when I'm feeling a little bit more relaxed about my classes. All right, happy enough, everybody? Well, all the very best of luck. And just a little piece of advice: if it's 9:10 and you're starting to feel tired and you're thinking, it's a physics exam tomorrow, I'll maybe get to bed, I'll maybe go to bed here now, have a wee nap, or get up early in the morning. Just remember that you don't get cheetahs doing that. Right? If you get a cheetah out in the plains and it's hungry, it's going hunting a gazelle, and it's not stopping till it gets that gazelle. It's going to get a gazelle or die. Now, I'm not recommending that you either revise heavily for your physics exam or die. That's maybe slightly hyperbolic, but get yourself down to work. You've definitely got enough time to get at least one more past paper crammed in before hit the hay early, get up early, get your last minute prep done, and be ready for this exam tomorrow. All the very best of luck. Physics rocks, and it's true, but hopefully you rock, and hopefully that's true too. Good night, everybody, and all the very best of luck.